It's going to increase. What word tells us increase? Yeah, why in exponential growth, what tells us it's going to increase?
No,
what word? The word growth, right? Growth is telling me that it's going to be getting larger, bigger. It's going to increase. And exponential, what is it going to have to contain? Not just an exponent, a variable exponent, correct? Exponential growth, by definition, is a quantity that increases at the same rate. Exponential growth is a quantity, a value, right? Exponential is a number, yes? That grows at the same rate over time. Exponential growth. So there are two types that we're going to work with here in middle school. If this is something that really interests you, economics is a great course to take when you get to high school. Personal finance.
Like in real life.
I mean, it depends on what you do. If you don't deal with exponential growth, I mean, all right, basic interest. So this is the idea, if you've ever, or as you grow up, you're watching the news and they talk about the cost of living and how it increases, I think, what is it, 2.5% every year is the theory.
Oh, yeah. They're trying to make you not live.
So,
and then tuition increases.
Right, so these are basic interests. These are things that just like every year we can predictably say that the cost of college is going to increase, right? Basic interest. We talk about the cost of living. That's basic interest, right? The podcast I was listening to today talked about how a woman was paid $25 in 1978 for something. She got $25 for it, which is the equivalent of $97 today, right? Basic interest. Things that are increasing over time. So, our formula is y equals, because we can graph it, right? It predicts, it follows the same pattern every time. A, and then we do the number 1. And that number 1 signifies 100. Because basic growth, if I start out with $10 and I multiply 10 by 1, I don't lose any money, correct? I'm not losing money off. I'm starting with my initial value of A, and that 1 means I'm sticking with it. And then we're going to add the rate. So if I have $10, I'm going to do $10 times 1. I'm going to keep my $10, but then I'm also going to add in the rate that I'm earning. And then we have to make it exponential. So the power of t.
Is T time?
T is time. Yes. All right, so here let's break it down. Y is my answer. A is my amount. So the number, right? R is my rate. And T is my time. And I'm going to change my example from first hour because I don't like it. Okay. Let's do this. It says you may have to help me with this. A college credit hour costs approximately how much? Okay.
Single hour, like for the whole year?
Yeah, and you take 3 at a time. Like a class is usually 3 hours, sometimes 5.
That's really dumb.
a college course costs, so let's say it's $2,100. I know. It's expensive. Ridiculously expensive.
Why?
They don't want you to
Because
notice.
people will pay it. I mean, it's supply and demand.
The government's trying to make you notice.
What's the supply? The rate of college has increased more and more.
Because they can keep raising the price and people will continue to pay it. They haven't hit a bubble yet.
Someone's got to pay
This
those salary.
generation.
So a college course costs $2,100 and increases at a rate of 3.5% per year. Now again, you're not writing a check for this right away. You can get a loan so that you don't pay it off, and we'll talk about loans later in compound interest. You can get scholarships, right? So lots of things. Everybody stop panicking, but here's your real life moment. This is why your grades are important, right?
No, they really are.
How much will it cost in 9 years? How much will it cost in 9 years? All right, so let's talk formulas. Y equals A parentheses 1 plus the rate to the power of t. The more you write the formula, the more it sticks in your head, correct? I get it. It's written right here. Write it again. I know, life is difficult. All right, so let's substitute. Y equals A. What's my initial value? $2,100. $2,100. Times the quantity. 1. Because I'm paying that amount, right? Plus, what's my R? What's my rate?
3.5.
It's not 3.5, it's 3.5%. So what should I put? Don't put 3.5. You'll really have a heart attack if you put 3.5.
That's what I did.
Make it a decimal.
Because it's not 3.5, it's 3.5%. It's 3.5%. And percent means of 100, right? If you cannot change in your mind 3.5 to a decimal, you take 3.5 divided by 100. Moves your decimal 2 times. To the power of what? 9. All right, then comes the magic of the calculator.
Yeah. I'm gonna see if you can tell anything else. If you know I can't do it, then it's maybe right.
Now is the magic of the calculator. Now here's a little other insider tip. If you're being asked to pay, they will always round up to the nearest cent. Even if it's like a 0.4 cent, right? They're always going to look for more money. But if they're paying you, they will never round up, even if it's 0.8.
Then they're slimy dogs.
Because they're wanting to save their money, right?
That 1 penny really counts.
Listen, that 1 penny really counts over time.
Multiplied by how many kids attend the college. So
How
literally
much
1.8.
is 2,100 times parentheses, right? 1 plus 0.035, close parentheses to the power of 9.
2,862.
So y equals 2,800, what? 62 and how many cents? 10 cents.
Is that like 'cause you're going to the
Is that right? Everyone got that?
If you do 3.5,
Right? Yeah. That's one course, which is 3 credit hours. To be a full-time student, you have to be at 15, 12? I don't know, 12? Yeah. So that's for 3 hours. So multiply that by 4, that's 1 semester.
Yeah.
Ugh.
And that's a state school.
Right, right.
My kids are private schools or way more.
I'm not going to college.
Yes, you are.
Listen, don't scare it. You just have to get scholarships.
You don't have to.
Well, I mean, I guess that's right. You don't have to get a scholarship.
Yeah, Jordan. That's so good.
All right, so basic interest. Basic interest is exactly that, basic. There are no extra factors that go into it. The next one we're going to talk about is compound interest. It has extra stuff that goes into it. Compound interest. Here's the idea behind compound interest. Basic interest, cost of living, things like that, very minimal. Just it does the same thing every year. It's predictable. Compound interest. This is where it comes into credit cards, right? Credit card, I just swipe. I'm borrowing money from that company, and at the end of the month, they say, all right, Mrs. Long, you owe us this much money, and I have to pay it back. And if I don't pay it back, they charge me interest, correct?
Payday loans.
We got payday loans or compound interest. Car loans, right? Very few people out there in the world walk into a car dealership, write a check, walk out with their brand new car. Even fewer people out there go into a bank and say, oh, I want to buy that house. Here's my check for $140,000, right? Very few people say, oh, I'm going to go to college. Here's my check, right? You get a student loan. You get a car loan. You get a home loan. All of these loans out there that we have to use charge this thing of compound interest. And there's a formula. Now this is the basic compound interest formula because it can change. It looks like this. Y equals, and P, we change from A, which stands for amount, to this letter P, which stands for principal. It's just when you deal in the financial world, their word for initial amounts of money is called principal. Okay? And it's always times 1 because, again, we're starting with our value, right? That's where we are beginning. They're not giving us a loan based on $5. They're giving us the loan based on how much money is actually in there.
The principal is what you bring to the table.
Plus, and here's the change, R over N. So we have a fraction in there. Then we close our parentheses, and then our exponent is N times T. Now here's the deal. I talk about this in the world of loans, right? Like me borrowing money. This also works in the idea of me saving money. So if I have they're called high interest savings accounts, right? If I go to a bank, and every bank when you walk in shows you their percents, their loan percentages, their savings account percentages, all of these things. I go into a bank and I say, all right, here's my $500. And I put it into this savings account, and then I don't touch it. That's the key, right? Don't go in there and take money out of it. You want to keep it in there. The bank is going to say, oh, you know what, Mrs. Long, thank you for giving us this $500. We're going to pay you some interest for letting us have that, because that's how banks work. Banks work because they don't have all of that money just hiding in the basement. Right? Banks work because I give them my money, and then they are very good at what they do. They then use my money that's in there to help someone else with a loan, and then give me my money back. And that's the idea behind a bank. Every bank doesn't have $1 billion just sitting around waiting to hand out to people. So compound interest, they're paying me for getting to use my money. Right? So it's not just me having to pay interest rates, right? Banks can pay me interest rates. All right, here we go. So this is different because not only does it pay interest, but it pays on both. It's going to pay on your principal and on the interest earned. Now I will tell you this. A bank is not going to give me a huge percentage. You're lucky if you can get sometimes 0.5%. Now a credit card company will charge me 25% interest.
They want the money.
Well, yeah, and they can't. I mean, they're running a risky business. You go out there and buy $10,000 worth of stuff and you don't pay it back.
Whoa. And they take away your house.
Yeah, then they come after you.
Yeah.
Yeah. All right, so compound interest is going to pay on both the principal and the interest. Simple interest just pays on that beginning value. It just increases every year. All right, here we go. Example. You save $1,000. Let's make it easy. In a savings account. Now again, I'm telling you, this is not a regular savings account. These are one of those fancy savings accounts, right? They're high interest savings accounts. If you don't have enough money in it, yes, you have to pay for it.
Monthly.
Not plural, savings account. That pays, and again, this is not going to happen for you. 5.5%. Yeah, these are no longer the days of,
70s, 80s.
yeah.
You can get 3%.
Right? So you save. We've got this great account. And it's going to compound quarterly. Maybe someday these interest rates will come back. It's going to compound quarterly. What does that mean? It compounds quarterly. 4 times a year. 4 times a year, quarterly, quarter, 4.
Wow.
4 times a year, they will recalculate how much money to pay you. What if it said monthly? How many times would that happen? What if it said annually? Once a year. Ooh, biannually?
Every 2 years.
Twice a year.
Oh. Wow. Why don't they just say every 6 months?
Because every 6 months is a lot more words.
And it's all about saving ink. We need money.
All right, so we compound quarterly. How much will you have in 5 years?
A lot of fives.
You save $1,000 in a savings account that pays 5.5% that compounds quarterly. How much will you have in 5 years? So let's write the formula again. Y equals the principal, P, times 1 plus the rate over the number to the power of NT. Ooh, let's define. Good call. Y equals the answer. P stands for principal. Oops, P-R-I-N-C-I-P-L-E. Not pal, but pole. R stands for the rate as a decimal, correct? N stands for the number of times. and T stands for time. All right, substitute. Who's got it for me? Who can tell me my formula? Y equals what? What's my P? What's my principal? $1,000. Times the number 1. Always the number 1 because we're multiplying by the amount that we start with. We're going to add, and what's my rate? It's 5.5%, which I need as a decimal, so 0.055. Divided by 4, because that's the number of times, it's quarterly. To the exponent, my power is 4 times 5 years.
What do you have to do to get the 1 to not be 1?
Okay, it's quarterly. Yeah, but I'm not sure. Yeah. 4 times 5. That's 25.
There are lots of nothing that you would worry about at this moment.
Every time there's 5.
All right, now it's time for a calculator. How much money will you have in that savings account? Remember, all you did, you walked into the bank, you gave them $1,000, you walked out. Don't touch it. You come back in 5 years. So the bank is what? The bank is going to give you an extra cent or not?
No.
They're not. You can continue to round it. That's fine. I'm just saying, like, don't go in there and be like, oh, excuse me, the bank took 1 penny from me. They're not gonna pay you that extra penny.
They're refusing to pay you money.
I got
Isn't that illegal?
314. I got it. It's 1,000. I got 1,000.
Not about the money, it's about the respect.
Okay, here we go. Let's try it.
Oh, I put 4.5.
100,000. 1 plus, sorry.
That's like how I was speaking yesterday. Remember that, Talia?
Over 4 to the power of 20, correct?
That's 4 times 5.
$1,314, and you could say 7 cents. You could say 6 cents.
So it would be 4%. On a test, would it matter which way?
I will make it so that it doesn't do that on a test.
Is it 6 or 7? Either one. Oh, I'm 7, so I get it.